Good morning, world. We're on day 4 of the 30-day LeetCoding challenge. Let's check it out. Today we have move zeros. Given an array nums, start writing out our problem here. Given an array nums, which I assume only has integers. Write a function to move all zeros to the end of the array. Move all zeros to the end of the array while maintaining the order of non-zero elements. Okay. Maintaining order of non-zero elements. So if it's a zero, if it's not zero, then we keep it in the same order as it was with other non-zero elements. So let's look at this example and it'll help explain it some. We've got, let's copy it. So 0, 1, 0, 3, 12 yields 1, 3, 12, 0, 0. So the non-zero elements in this one are 1, 3, and 12. And in the end, they're still in that same order, 1, 3, 12. What we don't know from this one test case is what happens if the array is empty. And if the array has only one element, I believe it just returns the same one. So I'll include test cases for those, but just something to be aware of. And then also, what happens if we have a negative number? So if we have negative, we'll go 0, -1, 0, 3, 12. I'm thinking that would give us -1, 3, 12, 0, 0, because we're not ordering the zeros based on their actual value, where they would be directly after the -1, like this, like -1, 0, 0, 3. You get it. We're not ordering it like sorting, we're ordering this so all the zeros at the end with the other elements in their original order. So the essential problem here is just move zeros to the end of the array, keeping everything else in its original order. So 2 notes on this. Minimize total number of operations. That goes without saying. You don't want to be redundant. And do this in place while making a copy of the array. Okay. So that means we can't do something like this, which would actually make it a lot easier. Like we can't do let new nums equals nums.slice and then edit that array while we go over the original array. So we can't do this. We have to actually modify the original nums that was passed into the function. Okay, so notes must modify the original array. Must modify the original array. Okay. No copies allowed. Okay, so data structure. I'm thinking a queue would help with this problem, because essentially I need a way to keep track of the 0 indexes as I traverse the array. During traversal. If element is non-zero, check, I guess, collection of 0 indexes. If there is an index, what would I use to modify it in place? I think it'd be splice. Yeah, I think it'd be splice. Splice the current element's value to the 0 index, and then we would get rid of the current one. Splice the current element out of the array. I'm pretty sure splice, I don't think it returns a new array. I think it modifies the original, but I'll have to check. If element is 0, let's see, we want to push put the element onto the collection. I'm not sure what kind of collection I want to use yet. I'm thinking queue, but I want to think about this a little more. Put the element onto the collection, and then just move forward from there. So I'm thinking either a queue versus a stack in this situation, and just to kind of give a brief overview. Queues are first in, first out, which means, for example, if we have the following numbers in our queue, 1, 2, 3, 4, the 1 would be removed first as we go through it. So then we lead off with 3, 2, 3, 4, 3, 4, and 4. It's just like in a restaurant when people, well, I feel like fast food, when everyone's waiting at the line in a queue, the first person is the first one out of the line, and the last person is the last person out. This is different than a stack, where if we had the same example, 1, 2, 3, 4, the last one would be the first one out. So we would have 1, 2, 3, and then 1, 2, and then 1, 2. I mean, then one left over. I'm thinking, let's see, so queue versus stack in this situation, we want to modify the if we used a queue, we would get rid of the first one first, and if we had a stack, we'd get rid of the last one first. So let's use an example from up above, 0, 1, 0, 3, 12. If we are iterating through that, our first element is 0, which we would push into, let's say it's a queue for this one, we'd push it into a queue with the index, which is 0. So here the element is not being pushed into the queue, the index of that element is. Next we have 1, which we check to see if there's a 0 index in our queue, and there is, so we splice the 0 index with the current element's value and get rid of the current value, which gives us 1, 0, 3, 12. Oh, we need to push the 0 on the end of the array. Put 0 at the end of array. And then we also need to get rid of element from index from collection. So it'll look like this. Yeah, that looks better. That looks better. Looks much better. Now there's a problem in this where, since we're modifying the array as we go over it, the indexes can get tripped up very easily. Because in this situation, if I'm doing, like, say, for let I equal 0, one of these where I'm incrementing it by 1 each time, we would go 0, 1, and then our index is 2 on the next iteration, which would put us to 3, which means we would skip the 0 after the 1. So if we are performing one of these operations where we need to splice, we should subtract 1 from the counter, since the current element will be the next element, next iteration. Okay. So taking care of that, now our next iteration will be at index 1, which is 0, which we append onto that, which is our 1. Remember, 1 is the index of 0 now. Next element is 3. Since it's not 0, we check the queue. There is a 1. So we splice, do all that stuff, which gives us 1, 3, 12. Remember, we push the 0 onto the end of the array, which actually gives us our correct answer. And then last, we go with 12, which gives us, which is non-zero, and the queue is empty, so we don't do anything. We just leave it as is. So how am I going to know that we are done? Well, basically, we would be done at the end of So now this is the next problem, how to tell if we're done. Because the index we're actually ending on here is is 3, because we went 0, 1, 1, 2, 3. But our length is 5. So we can't end it by the length of the array. We could do the length of array minus number of zeros. Because at the start, that would be 5 minus 0 is 5, so we'd end there. Then once we have 1, 0, gives us 3, we'd end it. 3, and 5. And then the once we have 2 zeros, it would end us at 3. Next would be that. So I guess the algorithm could be if length of array minus, so if counters equal to length of array minus number of zeros, break. So then we need to keep track of the number of zeros as we go through the array. So that's another kind of counter. So we'll start that as 0. So I want to use a queue in this situation because I think it makes sense to replace the first element with the first index with the first element we see. We want to do this in order. So right here's our algorithm. We're going to use a queue and a integer for number of zeros. And what else is there? And then an integer for counter in array. Okay, let's see here. We have that number of zeros to 0. We start there. And let q equals empty array. For let I equals 0, I is less than nums.length minus number of zeros. And then we increment at the end of each term. So if, we'll just check first if it's a 0. If nums I is equal to 0, we want to q.push nums I so if it's anything else we know that it is not 0, so we don't need to check for it, but we should check if continue here. If q.length is greater than 0, then we know we need to splice push 0 onto array and decrement 1. And also shift from q. So let's look up the splice here. I want to make sure I'm using this the right way. So we can insert at a given index, like in this one, where at the index 4, starting there at 4, we replace one index with the element may. So replaced 1 at the 4th element with the element 1. Let's see if we change this to 0. Or actually just 1, but without a replacement. Okay, so we got rid of it there. That's good. So essentially we want to do num slice. Actually, let's do shifted index. We'll shift it right at the start. Shifted index is equal to q dot shift. Is that correct? Or is it unshift? Yeah, it removes. Okay. Good. Then we want to splice. So we'll do nums splice shifted index 1, and we're replacing it with nums I. We do decrementing, and we'll splice the current index, which is I, and then we remove 1, and then we push 0 onto the array. We'll do that here. Nums.push 0. I'll send the increment number of zeros here. See if I've implemented this well. So if the element is 0, we push the element into the queue, we push the index into the queue, an increment number of zeros. Then if the collection of 0 indexes are queue, if the length is greater than 0, which means it has at least one element, we're going to shift the first one, splice that 0 index with our current value, then get rid of our current value, and then push 0 onto the end, and decrement the counter by 1, so we actually move to the next element and not the element after the next element. And then at the end here, we'll return nums. Let's see what happens if I run it. 3, 0, 12, 0, 0. That is not right. Let's see at what indexes we are slicing. At 1 and 2. So at 1 and 2. That seems to be correct. Let's make sure that the right numbers are there. It's the element. 1 and 3. Those are the right ones. Let's take a look at Q for each. Oh, I think I found my problem. I'm pushing the actual element there. So I was pushing the element and not the index. Let's see if it works now. Yep, that worked. That was good. Let's try our test cases that were kind of outliers. They didn't give us empty array, an array of 1, and then the same array as the example one, but with -1 instead of 1. Okay, those all worked. That's good. Let's make up one more. 9 0 0 4 0 12 0 4. Okay. So right here, I included this test case because it has 2 zeros back to back, and we had a problem with that. We're supposed to have 4 zeros at the end, and here we have a 4 in the wrong index. So let's get rid of these test cases for now. We'll put them up here. And I want to see which index we are ending on when we run this. Ending on the 4th index. So that means 0, 1, 2, 3, 4. Okay, so we ended it before that 4. Let's see at which indices we are splicing. We're splicing at 3 and 4. We're only doing that twice. We're only splicing twice when we should be splicing 3 times. Let's see what happens if we make this num's length instead of number of zeros. Okay, that worked. It'll take a few more iterations, but it works. So let's see if we put these test cases back in, if these work as well. Expected end of JSON input. What does that mean? let's get rid of these test cases. Just keep the original. Find one. Unexpected end of JSON input. I don't know what that error is. I'm gonna paste my test cases into here. Paste the test cases, and I will copy that, and I'll just start this over. Let's see if this works. Could it be the var? Is that right? Let's see. Computer's going a little slow. Okay, there we go. Unexpected end of input code. Test case empty spaces. Don't know what this error is. What happens if I just submit? Oh, okay, it worked. Well, I'm not sure what the problem was, but the solution worked, so that's all that matters. Ooh, 94%. Pretty solid. Nice. Thank you for your patience. Have a great Saturday.